So we need to simplify square root of 112, a to the 6th. So with this problem, we're going to separate the numerical part and the variable part. So I'm going to rewrite it as root 112 a to the 6 being equal to root 112 times root a to the 6th. That way we can deal with the number term and the variable term separately. So with the number, you have to make a tree. So we have 112, and it's an even number, so it's 2 times something. And it looks to be 2 times 56. 56 is an even number, and that would be 2 times 28. And 28 is 7 times 4, and 4 is 2 times 2. So lots of 2's here. Let me just circle all of the ends of our branches here. So 112 we're going to rewrite as the square root. We have 1, 2, 3, 4 2's. So it's 2 to the 4th times by 7. And then over here we have root a 6th, a to the 6th. And when you have variables, you want to rewrite it as a product of that variable squared as many times as you can. So we have a squared times a squared times a squared, since in total you would still have 6 of these a's multiplied together. And for each a squared, square root of a squared technically is the absolute value of a. And in later exercises, when you're simplifying square root expressions, you actually assume in these problems that your variable is positive. Now in these, they don't mention it. Technically, they probably should, but they don't. So you just have to be careful with this. And frankly, we're just going to ignore it. We're just going to assume that a is a positive value here so that we can make these simplifications. And so the square root of a squared, we're just going to say this is a if a is positive, and we'll just assume that it is. So for this term here, this square root of numerical terms, square root of 2 to the 4th. Now 2 to the 4th is 16. So 2 times 2 is 4, times 2 is 8, times 2 again gives you 16. And the square root of 16 is just 4. So I'm just going to rewrite this as root 16 times root 7. And then each of these is broken up into its own square root. So we have a product of these square roots. And this is 4. And each of these is a. So you have 3 a's multiplied together. So you have 4a cubed. And then root 7 has to be left on the inside since we can't simplify that. So our final answer here, what we'd put in the box, is 4a cubed times by the square root of 7. And let's keep going with these problems. So again, with this one, we're going to deal with the numbers and the variables separately. So you have root 39 times by the square root of y to the 9th. This one, they do assume that y is a positive value. And so from here, we make a tree for our numbers. So 39 is really just 13 and 3, and neither of those is a perfect square. So the square root of 39 will stay in the square root. We won't be able to simplify that. Now y to the 9th, we can simplify that. So let me just rewrite this. Root 39 times, we have y squared times y squared times y squared times y squared times y. So I just wrote this out as a product of a bunch of y squared terms together, and then you have that remaining one. But if you count them, notice that you still have 9 y's. And so we can simplify this, root 39. Each of these y's will give its own square root, so square root of y squared. We've got 4 of these, so that each of these will result in just y on the outside. So you have 4 y's on the outside, or y to the 4th, and then you still have that root y, which you won't be able to simplify that because it's not a perfect square. So like I said, these all just become y, so you get y to the 4th on the outside, and then root 39y has to be left on the inside. So we can put in the box, let me make it darker, we have y to the 4th times the square root of 39y. And moving forward, and again, we're just going to simplify it, deal with the number terms and variable terms separately. So root 108 times by root a to the 6th. You can always break up a square root if it's a product. If you're adding or subtracting, you cannot do this. It's only when you're multiplying or dividing under a square root that you can break it up into a product or a quotient of 2 square roots. Now, root 108, we're going to make a tree for that. And it's an even number, so it's 2 times 54. 54 is even, and that's 2 times 27. And 27 is just 3 threes multiplied together. So I'll just break it into a triple branch there. And so 108 is, there are 3 threes, so 3 cubed times 2 twos, or 2 squared. And I like to write it with perfect squares. So instead of 3 to the third, I'm going to write it as 3 squared times 3 times 2 squared. That way we can highlight our perfect squares, which we can actually take out of the square root. So rewriting this, you'd have the square root of 3 squared times 3 times 2 squared. And now we deal with the a to the 6th term, which we'll just write as a squared, but we'll do that 3 times. And sometimes I'll write it like this because it's much shorter, but sometimes I'll write out a squared times a squared times a squared. So however you want to do it, but this way is the way I'll probably do it in practice. Now, this square root, since you have a product, we can break it up into individual ones. So root 3 squared times root 3 times root 2 squared. And then this one, we can simplify. Since you have a square root and a square, in fact, you can switch the 2 and the 3 if you want. Make this root a cubed squared. So then you have this thing, and you're squaring it and square rooting it. So the square root and the square are going to cancel, and you just get a to the third. But you could have also written it out as a squared, taking a square root of each of those, and you'd get 3 a's in the end, which is just a cubed. So either way you do it works. And then square root of 3 squared, the square and the square root cancel, you get 3 there. Same with the 2 squared and taking its square root, you just get a 2. And we've got a cubed on the outside, and then root 3 will be left on the inside. So 3 times 2 is 6, so you get 6a cubed times by the square root of 3. So that's what you'd put in the box. So 6a cubed and root 3. And let's do another one. So we need to remove all perfect squares here. We're assuming y is positive in this one. So separating it, we get root 200 times by the square root of y to the 4th. We'll make a tree for 200. That's just 2 times by 100, and 100 is just 10 times 10. So 200 is really just 10 squared times 2. And y to the 4th, I will rewrite that as y squared times y squared. So y squared times y squared for this term, and this was 10 squared times 2. Now we want to separate it into individual square roots. So we can make this root 10 squared times by root 2, and this one can be root y squared times by root y squared. Or if you want, you can make this like root y to the 4th is really just square root of y squared squared, and then the square root and the square cancel, and you just get y squared in the end. But in each of these, you would just get y, and then combining them makes y squared. So root of 10 squared, the square root and the square cancel, you just get 10. Or really, this is the square root of 100, which is 10. And then you get your y times y on the outside, which is y squared. And then root 2 has to be left on the inside, since 2 is not a perfect square, so we can't take it out. So that's what we'd put in our box here. We'd have 10 y squared times by the square root of 2.